Hello, everybody. Welcome in. We'll give it like a minute or two while folks trickle in. Okay, I think we'll go ahead and get started. Hello, everybody, and welcome to our Affordable Housing Electrification Training Series. My name is Angel Rodriguez. I am with the Sustainable Housing Program team here at the California Housing Partnership. Today, we bring to you our third session of the series, in which we'll focus on the operations of all electric housing. And during this session, we'll be diving into the operational aspects, the benefits, and ultimately the overall considerations associated when switching to all electric. We'll also be using our time today to explore the equipment that's involved in all this and the maintenance entailed with all these newer technologies. So definitely stick around, lay back, take a sip from your coffee, as this will officially mark our halfway midpoint of the training series. So before we begin, I'd like to formally acknowledge all the key contributors who have made this training series possible. First and foremost, we extend our immense appreciation to our financial sponsors, the Wells Fargo Foundation and Energy Efficiency for All. We also want to extend a special acknowledgement to our housing partner, SCAF, the Southern California Association of Nonprofit Housing. They have been very instrumental in providing a lot of the logistical work and pretty much helping us coordinate this great virtual event for you all. And lastly, we'd like to express our appreciation to our program partners, LIWIP, the Low Income Weatherization Program, MCE, SOMA, Solar on Multifamily Affordable Housing, TEC, and BUILD, the Building Initiative for a Low Emissions Development Program. We just thank each and every one of these organizations for their efforts and support into making this affordable housing electrification training series possible. And so for a quick recap, this is training number 3 of the series, in which will cover the operations of all electric housing. Next Wednesday on the 27th, we have accelerating electrification with solar energy. In this training, we'll be covering the significance to solar PV, so solar photovoltaics, and also highlight the advantages it has to offer for affordable housing providers and residents. And then our last training is on October 4th, financing and funding the electrification of new and existing affordable housing. In this training session, we'll focus more on the clean energy resources and the finances that are available for energy efficiency upgrades. And if you weren't able to attend any of the previous trainings, don't worry. There's definitely the PowerPoint decks and recordings that should have been available and sent after the training. But if not, also feel free to check out SCAN's YouTube channel, and you can access the recordings there as well. And so, yeah, before we dive into our presentation, I'd just like to cover a few housekeeping items. This session is being recorded and it'll be made available to all attendees after the training. So in case you miss anything or you want to revisit a certain section of the presentation, you'll definitely have the chance to do so. Plus, we will also be sharing the PowerPoint deck with you all, so you can always refer back to it at any time. And also, please feel free to use the Q&A feature located at the bottom of your screens. In case you have any questions or so on, we'll just be closely monitoring this section of, this feature. So definitely feel free to type away. We'll just be addressing your questions towards the end of the presentation we have a set time for a Q&A section. And so to just get a sense of some concerns to switching all electric, we ask, what is your primary concern when considering a complete shift to an all electric system for an entire building? We're just kind of curious to see where folks may be hesitant in the process, if there's something holding them back, any difficulties, such as safety concerns, costs, maintenance. So by now you should have received the poll question popping up. And in case none of these apply to you, feel free to select other and use the chat feature as to what that other may be. So I will probably just give like a minute or two to see the results that are coming up through here. Okay, so it looks like a majority is under the cost and affordability. And the second runner-up will be electrical infrastructure. So yeah, it definitely looks like there's some main concerns with the cost and affordability. Good thing we do have a training coming up on how to finance these different energy efficiency upgrades. But yeah, thank you everybody for submitting your answers. We hope this training session will further solidify your decision into going electric and the benefits it has to offer. So yeah, with that being said, let's go ahead and get started with today's training. Our presenter today is an expert in the field and has a great wealth of knowledge to share with you all. He joined the Association for Energy Affordability in 2017 and has been committed to addressing energy, carbon, and indoor air quality for various projects. So providing his utmost service to multifamily properties, please help me welcome with a round of virtual applause, Jack Aitchison.
Thank you, Angel. Appreciate it. Like Angel mentioned, my name is Jack. I will be presenting on operations of all electric buildings. Next slide, please. So just the agenda, we're going to start with some myth busting, then we're going to go into some specific systems, HVAC maintenance, water heating maintenance, induction cooking maintenance, and then solar PV maintenance. And then we're going to focus a little bit more on the operational side and the managing side, and we're going to look at the importance of utility monitoring, resident education, and then we're going to have a quick preview for the next webinars. Next slide, please. So starting off with myth busting, next slide. So the myth, all electric buildings are more expensive to operate and maintain than gas systems, but is this really true? Next slide, please. So I'm going to essentially address this myth by explaining where this is coming from. So essentially, a lot of the reason why we have this misconception that all electric buildings are more costly to operate and maintain is because of deferred maintenance of electric appliances. And when I talk about electric appliances, I'm talking HVAC, water heating, and just appliances in general. But all electric appliances are significantly more energy efficient than gas, and electricity is more expensive than gas. And so when you have that really high efficient equipment, what's going to happen is if you have deferred maintenance, the efficiency of that equipment is going to drop. And due to the cost of electricity, as well as the range of efficiency that we have of all electric appliances, we're going to see that in our utility bills. And so that's sort of where this myth comes from, that all electric buildings are more costly to operate and maintain, is because when you don't maintain them properly, you are going to see an increase in your utilities. And as an owner, that's what you're going to notice. However, there's a huge benefit of going all electric, which is dangerous issues are unlikely. So you're not going to have combustion safety issues associated with all electric appliances, whereas that could be the case for gas. Next slide, please. So moving on to gas, deferred maintenance of gas systems, you're probably not going to see that in your utility bills. And there's two main reasons for that. Well, one is gas is less expensive as a fuel type, but in addition, gas appliances are already really inefficient. So your peak efficiencies of gas systems are going to be around 95%. Most of the people that have standard gas appliances are going to be in the range of 65 to 80%. If you are deferring maintenance on gas appliances or gas systems, you're probably going to see a drop of 5, maybe 10% of the efficiency of that system. Whereas for electricity, you could go from 300% down to 100%. That's going to be a significant drop. And then in addition, gas is just less expensive. So even if you have a slight increase in gas usage, you're not going to see that in your utility bills. And so, that's sort of where that myth comes from. However, deferred maintenance of gas systems do result in dangerous combustion safety issues. And so that may not be something that as an owner or as a property manager you see unless you test for it. And the Association for Energy Affordability implements a ton of energy efficiency and electrification programs throughout California. And in all of those programs, there's an aspect of combustion safety testing that we do. And a few years ago, I decided to put together some data associated with that combustion safety testing. And so from that analysis, we tested 1,209 dwelling units, 1,812 combustion appliances were tested, and around 49%, close to 50% of those units had some sort of combustion safety issue, either dangerous or preventative. And when we're talking dangerous, we see some photos here on the right. We have high carbon monoxide in a wall furnace. We have a gas leak on a pool boiler. And then on the preventative side, we're talking recalled gas flex lines that are prone to leaking, backdrafting of appliances when fans are on, things that are considered preventative but not immediately dangerous. But this just goes to show that deferred maintenance of gas systems do result in combustion safety issues. And that is what we see when we're going out to properties and testing for combustion safety. Whereas with electrical appliances, if you have deferred maintenance on those appliances, you are going to see it in your utility bills. You're going to see an increase in electricity costs. However, I would argue that increase in cost is probably better than a potential dangerous issue that can occur at a building. Next slide, please. So jumping right into HVAC maintenance of all electric HVAC systems. Next slide. So there are two main types of HVAC systems that are all electric that we're going to see in buildings. We have heat pumps and we have electric resistance. Next slide. We should be really focusing just on heat pumps. Electric resistance is no longer code compliant in California. And heat pumps are really the catalyst to electrification and decarbonization in California due to their increased efficiencies. And because of those increased efficiencies, that's really where we're going to see cost savings and potential utility savings. Next slide, please. So sort of opening up the hood of a heat pump, these are all of the components associated with the heat pump. We have our indoor coil, we have our outdoor coil, we have our compressor, and we have a reversing valve and then refrigerant lines in between. I promise you I'm not going to go into much more detail than that, but these are sort of just like the components of what is inside a heat pump for HVAC. Next slide. And going back to those images previously, this is what you'll see when you're looking at a heat pump and sort of the location of these units. So on the left, we have our outdoor units, our compressors. This is going to have your outdoor coil, your compressor, your reversing valve. They're all going to be sort of in this box on the outside. And then flipping over to the inside, we have our in-unit air handlers. We have our mini split head units. We have our diffusers. This is what's going to be on the inside. This is what's going to have our indoor coil and our air filters. And then on the bottom, we have a packaged terminal heat pump where all of these components are going to be within that packaged heat pump. Next slide, please. So the things that need to be maintained within an HVAC system, our heat pump HVAC system specifically, we have our air filters. Air filters are something that should be maintained not only for heat pumps, but also for any central system that is distributing air throughout the unit, and package units as well. Duct cleaning, again, this is not specific to heat pump HVAC. However, if you have ducts, you should be cleaning them, you should be inspecting them. And ultimately, this goes back to the fact that by not doing these maintenance items, you are going to see an increase in inefficiencies and utility costs. And then heat exchangers and coils. Next slide, please. So we have a question here. How many of you have inspected your air filter in the past 3 months? No, wall furnaces and electric baseboards do not count. So we have a question, we have an answer there if you have a wall furnace or electric baseboard. But if you have a furnace, if you have an air conditioner, if you have a heat pump, you will have an air filter. And so the question is, how many of you have replaced their air filter in their HVAC system in the past 90 days? All right, I'll give everyone a minute to answer that question. All right, thank you so much. So, wow, the majority of you have replaced your air filter in the past 90 days. That is impressive. As someone who works in this industry, I admit that I have not done that. It's very common that people don't. So, looks like we got the majority of folks here are replacing their air filters, which is great. Next slide, please. So air filters, the purpose of an air filter, we sort of have two levels of air filter types. We have our basic filters that protect equipment. We have our advanced filters, which are MERV 13, which is California code. Those are going to protect your equipment and improve indoor air quality. And so looking at that diagram of all of the heat pump components, that's what goes in a heat pump. We're sort of over on the right, you can see that red box. That is where your air handler, or that is where your air filter is going to be located. Next slide, please. And so how to maintain filters. And I see we had a question come up in the chat. Recommended minimum maintenance. Inspect filters every 3 months, 90 days, and replace/clean as needed. Conditions affecting filter replacement frequency. If you are in a location that is dry and dusty climates, you're going to have a lot of particulate in the air that can come in through the windows, open doors. That is going to increase the frequency that you're going to need to replace your filters. If you have a dwelling unit with pets, pet dandruff, etc., that is going to increase the amount of frequency that you need to replace your filters. And then higher filtration rate will actually last longer. That's a little bit of a misconception that, if you have a higher filtration rate, it should get clogged earlier. That is not the case. Essentially what higher filtration rate is doing is it's a thicker filter, and that's going to allow for more filtration for longer. And then a recommendation here is to inspect filters while accessing dwelling units during routine maintenance calls and carry extra filters as well as cleaning solutions with you. There are two types of filters out there. There are one-time use filters, and there are also filters that can just be cleaned with a soapy water solution. And as a property manager or a property owner or maintenance staff, replacing a filter in every single unit every 3 months is going to be a difficult task in order to do. And really accessing the unit is probably the most difficult thing. And so you should have your maintenance staff carry filters and cleaning solutions whenever they're going to access a unit for routine maintenance. They should be inspecting the filter while they're in there. And then you should put together some sort of tracking solution in order to make sure that you're not missing units that need a filter replacement. And then you'll see this throughout the presentation, but on the bottom left, I have a difficulty rating for this. And this is really intended as I go through the presentation for folks to understand, okay, is this something that can be handled in-house, or is this something that I should hire a vendor for or budget for a vendor, etc. So starting off with filter replacements, the difficulty is going to be considered easy. All right, next slide, please. So consequences of deferring air filter replacement. Waiting longer than the recommended 3 months to inspect HVAC filters can impact indoor air quality and the performance of the HVAC system. So filter will stop filtering air properly. That is going to allow gunk and contaminants to enter the coil, which can get stuck to the coil and cause issues with transferring energy from the coil to the air. Dust and contaminants can enter the HVAC system. Coils become clogged, restricting airflow. Power draw increases to overcome issues less efficient. So essentially, you have a fan in there. If that fan has to work harder than what it's designed to pull air through that filter because it's clogged, that fan is going to work more harder, and that fan is going to burn out faster. So wear and tear on equipment is going to reduce the useful life. The coil may frost up. Ultimately, you have, when you're in cooling mode, that coil is going to have really cold refrigerant, and it needs to draw energy out of the air in order to avoid freezing. If it's not getting enough airflow because that filter is clogged, it's going to frost up. And then a condensate drain may be clogged and start to leak. And then you're also going to have a reduction in indoor air quality. If you are not properly filtering the air that is being conditioned, it could cause issues around indoor air quality. And then I think we had a question here, which is better, one-time use or cleanable, which is more expensive? Ultimately, it depends on the equipment. Package units, mini splits are going to have your plastic filter. Typical air handlers are going to have your one-time use filter. So it's not a question of using a plastic versus using a one-time use type of filter. It really depends on the equipment. Some equipment is going to have plastic filters, mini split head units. Package units are going to have those plastic filters, whereas your traditional air handlers are going to have those one-time use filters. Next slide, please. So ductwork. The design of ductwork is to evenly distribute conditioned air throughout a dwelling and return air back to the HVAC unit to be conditioned. Here's some photos of some ductwork that is poorly maintained. And then if we're looking at where we are in the building, again, this is sort of in the unit, not really connected directly or within the heat pump technology. It's what is distributed in the air. However, this can affect the efficiency of your equipment. So it's really important to make sure that your ductwork is properly cleaned and inspecting it. Next slide, please. So maintaining ductwork. Recommended minimum maintenance is to inspect ductwork every 3 to 5 years and vacuum as needed. Very similar to air filters. Conditions affecting ductwork cleaning frequency is dry and dusty climates, dwelling units with pets. Higher filtration rate will protect ducts longer. So if you have better filtration, there's going to be less gunk in your ducts, and you're going to have less frequently required to vacuum out those ducts. And then recommendation, inspect ducts while accessing dwelling units during routine maintenance calls, similar to the air filter. And then consider using a vendor for duct cleaning. Duct cleaning is a fairly, we have it as sort of the medium designation here. It can be done in-house. However, there are specific duct cleaning vendors that can do it much more efficiently and much easier. And so it may be worth it to hire a vendor for this. But what you should have your maintenance staff doing is inspecting ducts to make sure that they are free of clogs, free of dirt, gunk, that sort of thing. Next slide, please. So consequences of deferring ductwork cleaning. Waiting longer than the recommended 3 to 5 years to inspect ductwork can impact indoor air quality and the performance of the HVAC system. So dust and debris buildup can cause a decrease in air distribution effectiveness. Going into units all the time, I'm hearing, well, my bedroom doesn't get air, but my living room does. That's typically an issue with the ductwork, and that's going to result in people turning up their set points really high on their furnace, on their heat pump HVAC, whichever, or turn it really cold, trying to condition a space that the duct is clogged and conditioned air can't get to. Choking the duct from debris and dust can burn out the HVAC distribution fan. Again, these fans are designed to pull air through the coil and then push air through the ductwork. If we have a lot of gunk and a lot of stuff in the duct, that's going to result in sort of a back pressure on the fan, and that fan is going to have to work harder. It's going to burn out more frequently. Decreases efficiency of transferring energy from the coil to the air. Similar as the air filter, if we have a lot of back pressure from the duct because there's material in the ductwork, what's gonna happen is our airflow over the coil is going to be reduced beyond what the spec or what the design of the system is, and that's going to really impact our efficiency of conditioning that air and then distributing that conditioned air. Like I mentioned, certain areas of the dwelling not receiving conditioned air, and then if dust and debris is continually finding its way into ductwork, confirm filter is installed properly and upgrade to a higher MERV filter. If you're just in a place that has a lot of dust, a lot of contaminants, or if you're in a unit with pets, you should consider upgrading the filter to a higher MERV filter, so a higher filtration rate. Next slide, please. So moving on to HVAC coils. This is sort of the last thing that you need to be considerate of when maintaining heat pump HVAC. We have two types of coils in a heat pump. We have our indoor coil, which is located in the air handler or indoor unit, removes heat inside in the summer, discharges heat inside in the winter. Ultimately, our coils are basically all of the action of a heat pump. That's what's going to be transferring heat into the unit. That's what's going to be transferring heat out of the unit in cooling mode. And it's going to be sent out to the outdoor coil that's either going to be pulling heat from the outside to transfer into the unit during heating mode, or just dispensing heat that was from the inside in cooling mode. So really, this is like the crux of how a heat pump operates. So outdoor coils located in the outdoor unit. So typically, if we have a split system, we have our outdoor coil outside and our indoor coil inside. If we have a package unit, they're both inside. But most configurations for heat pump HVAC is outdoor coil outside, indoor coil inside. Next slide, please. So maintenance of heat exchanger coils. You should be inspecting these annually. Indoor coil cleaning should not be necessary unless you have air filter issues or indoor air quality issues. So ultimately, your indoor coil is protected by your air filter. And so if you are properly maintaining your air filter, you should not have to clean your indoor coil. It should be protected by that air filter and should be basically keep staying pristine throughout the useful life of the HVAC equipment. Outdoor coil cleaning frequency depends on environment and location of outdoor unit. So ultimately, these outdoor coils are subject to the outside. They do not have a filter with them. And so you really need to make sure that you're inspecting these outdoor coils because they're subject to outside elements and they don't have a filter. So this is really, when we're thinking about maintaining coils, you really should be thinking about the outdoor coil. And if you're doing your air filter replacements and inspections, you should not be worried about your indoor coil. If you have to clean your coil, you should refer to manufacturer specifications and requirements for cleaning. Some manufacturers only allow for you to do a light vacuum on the coil to sort of remove dust and debris. Some manufacturers recommend specific coil cleaners that are able to remove all of that dust and gunk off the coil. And then cleaning should be completed by senior maintenance staff. It does require taking apart the equipment. It does require someone that is knowledgeable about the equipment. So we don't want to accidentally, break the equipment when we're trying to maintain it. So it should be done by a senior maintenance staff person. You could also consider having a vendor do it. Within respect to the difficulty, inspection is very easy. Cleaning is medium. You should be inspecting your outdoor coils annually. And for your indoor coils, while you're doing the air, if you are noticing an issue with air filtration, you should be inspecting it. But if you're properly filtering, or if you're properly replacing your air filter every 90 days, or at least inspecting it, you shouldn't have an issue with the indoor coil. Next slide, please. So consequences of deferring cleaning of coils. So letting dirt and debris build up on the coils will impact the performance and energy efficiency of the HVAC system. Coils are the most energy efficient when they are clean. Dirt and debris building up on the coil can act as an insulator and hinder heat exchange between air and coil, can lead to reduced energy efficiency and indoor comfort. It's harder to clean coils that have become excessively dirty. So just to reiterate, what I'm presenting on are tools in order to maintain the HVAC equipment to keep its peak efficiency and maintain a low operating cost all electric building. Just want to emphasize that as we're going through this. Next slide, please. So just to compare HVAC, electric versus gas maintenance, starting off on the left, we have our indoor air filter inspection / replacement. For electric heat pump heating and cooling, you should be doing that every 90 days. For gas central furnace with a split air conditioner, you should also be doing that every 90 days. And then if you don't have air conditioning and you just have a gas central furnace, you should still be inspecting your air filters. And again, not replacing your air filters for a gas system, you're going to see maybe a slight drop of efficiency, but that could affect the equipment, that could result in a combustion safety issue. Duct inspection and cleaning. If you have ducts, regardless of the type of HVAC system you have, you should be inspecting and cleaning those ducts. Where we get to more specifics on heat pumps is indoor and outdoor coil inspection / cleaning. That's going to be required for your heat pump. That's also going to be required for your split air conditioner. Heat pumps are air conditioners. They can just go in reverse. So the maintenance is the exact same between a heat pump and a split air conditioner, or a packaged heat pump and a packaged window AC. The maintenance is going to be the same for those. And then the benefit of having an all-electric HVAC is you can remove all of these sort of like specific gas maintenance requirements. So checking for gas leaks, measuring carbon monoxide in combustion gases, checking ventilation and drafting. You don't need to worry about whether the unit is backdrafting or not. And then burner inspection / cleaning. That's sort of equivalent to the indoor and outdoor coil inspection / cleaning. So that's pretty much the same same approach. So it's very similar. And so as you can see, all electric, even though it's different, it's the same as air conditioning. It's just we have less items that we need to maintain for heat pump HVAC. Next slide, please. So moving on to domestic hot water maintenance. Next slide. So types of electric DHW systems. We have heat pumps. We have electric resistance. Next slide. And you may have guessed it, we are not going to talk about electric resistance because it's not California code and it's super inefficient. So we're going to be sticking to heat pumps. Next slide, please. So opening up the hood again of a heat pump water heater, these are the components that we have. There's a lot of misconception that we have refrigerant lines and we have a very similar setup as we would with the split HVAC system. It's really much more closer to a packaged terminal heat pump. So you have all of your heat pump sort of components in the outdoor unit and you have water pipes in between. And then you have your standard storage tanks that are going to require the same maintenance as you had with your storage tanks for your gas water heating system. Next slide, please. So just to sort of show what this equipment looks like based off the previous slide, on the left, you have your heat pumps. Those are going to have all of your, call them monoblock or packaged, but that's going to have all of your heat pump components within them. And then on the right, you have your just standard storage tanks. And then in the middle, we have residential heat pump water heaters. Residential heat pump water heaters are integrated. So you have your heat pump on the top and your tank on the bottom. They're all one unit. So it's sort of a little bit of a different configuration. Next slide. So heat pump water heater maintenance components. We have air filters again. We're protecting those coils. We have air to refrigerant coil heat exchangers. We have refrigerant to water coil heat exchangers. We also have a little bit of different topics than the HVAC, which is preventative DHW distribution maintenance, specifically crossover, and then preventative hard water maintenance. Honestly, the distribution maintenance is very similar to like ductworks. That would be the equivalent, is making sure that you're either distributing conditioned air or distributing hot water efficiently is going to keep your water heating system operating efficiently. Next slide, please. So just to go over a quick HVAC and heat pump water heater overlaps. You have an air filter. You should be inspecting those every 3 months / 90 days. For in-unit water heaters, bring replacements and cleaning items during routine maintenance visits. Ultimately, same thing as when you're replacing an air filter for an HVAC system. You want to get, if you have access to that unit, you should be bringing filters with you. You should be bringing cleaning solutions with you so that you can replace that filter for a during a routine maintenance visit. And then air to refrigerant and refrigerant to water coil heat exchangers. Refrigerant to water coil / heat exchangers are typically located within the package unit. So that's going to be in your outdoor unit or in your residential heat pump water heater, sort of like in the tank and in the top. Ultimately, you should not be inspecting these or cleaning these. They should be, if you're replacing the air filter properly, you shouldn't have any issue. They are protected by the air filter. However, you should be looking for error codes that indicate an issue and refer to manufacturer troubleshooting and requirements if an issue arises. Ultimately, heat pump water heaters, especially commercial size heat pump water heaters, are expensive right now as the market is transforming to them being the norm. So you really want to make sure that you're not trying to clean these coils and have, cause issues with the unit. So you want to, if you do see an error code or you do see an increase in electricity usage for whatever reason due to an issue associated with the unit, you should be contacting a vendor. Next slide, please. So leading into the distribution issue and maintenance side, How many of you have experienced temperature fluctuations while taking a shower in a multifamily building or a hotel? So I'll give you guys a minute to fill that out. Alrighty, so it looks like we have a lot of folks that have experienced fluctuations in temperature in a multifamily building or a hotel. Hopefully it's not happening in your building that you live in. Hopefully it's just a temporary stay or etc. But the reason for this, next slide, please. The reason why we have issues with fluctuations of hot water temperatures specific to multifamily and specific to hotels is because of the issue of crossover. Crossover is effectively when residents experience insufficient hot water delivery due to cold water entering the hot water line. So residents may experience cold slugs, temperature fluctuations, and water never getting hot. Increased water usage and water heating energy is going to be a direct result of having crossover. So crossover typically occurs in showers due to failed mixing cartridges. So we have a diagram here on the bottom left. What happens is you have a single handle valve, which you can see on the right. And inside that valve, you have these little shower cartridges, these little mixing cartridges. And these mixing cartridges will start to fail over time. And you will get cold water leaking into your hot water line and then joining the hot water distribution system. And that's why you have slugs of cold water. You have some, it's not always going to mix or fully mix. And so you're going to experience fluctuations in temperature. And that's really why we have those fluctuations in temperature is because of crossover. Next slide, please. So how to diagnose and repair crossover. Diagnosing, monitoring water and electricity bills for unusual high usage. That can sort of indicate that there's a crossover issue when people are using more water. They're also using more hot water, and your water heater has to work more frequently to recover that load, because as that cold water distributes throughout the building, if it comes back to the the return line to the water heater, that water heater is going to have to reheat that water, and it's going to have increased your load. Residents complaining of temperature fluctuations or lack of hot water. Perform a pressure gauge test to determine crossover existence and severity. A pressure gauge crossover test does require the cold water makeup to a boiler room to be shut off, and also draining of the hot water system. So you may want to have a plumber there with you. Measure time to temperature in different dwelling units in different locations throughout the building. And then repairing crossover. Repairing crossover is typically as simple as replacing shower cartridges. To prevent crossover from occurring, it is recommended to replace cartridges every 3 to 5 years. That is a difficult thing to do. That is expensive. It is not as simple as opening the valve. Oftentimes you have to sort of open up the opening that the valve is covering in order to get your hands in there and replace the cartridge. Typically, people are only replacing these cartridges whenever the tub spout has started leaking, or you're unable to close that shower valve all the way, and we're constantly getting dripping. And so if you ask a manufacturer who manufactures these shower cartridges, they say they should be replaced every 3 to 5 years. What would probably be a better approach for properties is to implement some of these testing strategies once a while, maybe every few years, every 3 to 5 years is probably good cadence of measuring temperature throughout the building. And then also doing like a pressure gauge crossover test. We also have this report that was written a few years ago, crossover repair / diagnose how to. It's really intended for asset managers and property managers to understand how they should budget and how they should approach in-house crossover testing. So it's a really great resource. And then the difficulty here is considered medium. We have a question here in the chat. My unit occasionally extremely hot water from the shower. I will answer this at the end. I have a lot of experience with crossover, but I'll answer this at the end. Thanks. Next slide, please. So hard water. Hardness is the amount of dissolved magnesium and calcium in water. Over time, these mineral deposits can cause buildup in pipes, fixtures, and water heaters. Test your water annually. It will change. Hard water can have a really big impact on the efficiency and performance of your water heating systems. And so if you have hard water, you should be considerate of how to minimize that impact of hard water. In addition, this is a really key, is that you should be testing your water annually because municipalities will switch their water source, and that will affect, and that how hard that water is will change. So if we're in a drought, oftentimes when you're in a drought, the hardness of water just in general gets worse. But in addition, your municipality may switch over to a different water source that could be very, very hard water without notifying you. So it's something that you should be testing annually. They make pretty inexpensive test strips that are really easy to use, very self-explanatory. It takes only a few minutes, and your maintenance staff should be testing this at least once a year. Next slide, please. So hard water impacts. The mineral deposits caused by hard water can cause several issues: reduced water flow and long wait times for hot water, heat exchangers not transferring heat properly, longer compressor run times, higher water and energy bills, leaking pipes, clogged pipes, reduced efficiency / poor water heating performance. In severe cases, pipes and water heaters may need to be replaced. Stuck check valves. The biggest the most vulnerable system to hard water are tankless water heaters. And when they first were rolled out, we had a lot of issues with hard water affecting these tankless water heaters. Heat pump water heaters are sort of in a similar category as tankless because they have such small flow paths that the water has to pass through. It's really easy for them to get clogged. However, you're not going to experience the significant failure that you saw with tankless water heaters where the whole water heater had to be replaced. You may need to replace components of the heat pump water heater. However, that's expensive, and it's much easier to just make sure that you include in your maintenance plan mitigating and preventing hard water and calcium and magnesium bicarbonate buildup in the heat pump water heater itself. Next slide, please. So flushing the system. Flushing both the pipes and tanks is essential to keeping mineral deposits from building up. The system should be flushed at least every 6 months and more frequently if hard water is a known issue. Water heater / tanks. Flush the tanks or tank type water heater with cold water until there is no sediment left. Descale heat exchangers, same process as tankless water heaters, and then replace sacrificial anode rods for tanks regardless of heat source. And then for the pipes, flush pipes with lime scale cleaning solution to remove mineral buildup. They do have food grade descaling equipment or descaling chemicals that can go into your water heating system and sort of protect the pipes as well to avoid buildup of calcium and magnesium bicarbonate. But if you have really hard water, if you're in Southern California, you should consider installing a water softener, and you should definitely hire a vendor to routinely flush the DHW system. It's much less expensive to have a vendor come out every 6 months and flush the system than to have to replace your heat pump water heating system or your gas boiler every 5-7 years compared to what their expected useful life of 15 to 20 years. And then I think we have a question here is, what is the recommended pH level for water? Hard water is measured in grains of calcium and bicarbonate, and that testing strip is going to tell you that. And if you have your manufacturer of the heat pump is going to give you a range of what they are okay with in terms of how hard the water is. And so if you're installing a heat pump water heater that is requires a certain grain level and you're exceeding that, you should consider having a water softener, or you should be really aggressive on the flushing the system and ensuring that you aren't going to have hard water issues. And just work with your manufacturer or work with the contractor that is installing the equipment to make sure that you're following the manufacturer requirements and guidelines. Next slide here. I think we have a question on in a gas to heat pump water heater replacement scenario, how do you deal with reduced recovery rate of heat pump water heater versus gas? quick answer is storage. I can go into more detail on that at the end of the presentation. HW electric versus gas maintenance. So required maintenance for gas versus electric, air filter inspection / replacement. That has to be done in heat pump water heaters. That can be done, or may be a requirement for gas water heaters if you have a condensing gas water heater. Crossover prevention, heat pump water heaters, you do need to do this. Gas water heaters, you should be doing this as well. One of the concerns and one of the reasons why crossover prevention is so important for heat pump water heaters, someone asked the question, how do you make sure that, with reduced recovery, how do you make sure people have hot water? Well, if you have an inflated load on your recirculation system, it's going to be even harder to maintain that load with a heat pump water heater because the recovery is so low. So it's very critical in order to maintain hot water and adequate hot water with a heat pump water heating system to take into account crossover prevention in your maintenance plan. And then sacrificial anode rod inspection / replacement. That's going to be for anything that has a tank. And then flushing heat exchangers for hard water. That's going to be your heat pump water heaters. That's going to be your tankless water heaters. And then check for gas leaks, all sort of the gas requirements of maintaining a gas water heater are included here as well. So just looking at this visually, as you can see, it may be a little bit different. It may look very different than what you're used to. It's going to be outside, but ultimately what it boils down to with the maintenance of the equipment, it's going to be less than a gas water heater. All right, next slide, please. So induction cooking maintenance, I'm assuming lots of folks are familiar with electric resistance coil cooking, so we're not going to touch on that, but we're going to talk about induction cooking. So tenant satisfaction, cleaner, safer, healthier kitchens. There's a great video on YouTube where someone cuts a pan in half and then fries an egg on an induction stove, and only half the egg fries because induction is heating the pan only, and so it's safe in that respect. It can also be so safe from like children burning their hands or adults burning their hands. In addition to that, it also reduced fire risk. There are marketing opportunities for including induction. Induction is a hot item. People love it. It is able to provide the same cooking experience as gas without all of the issues that are associated with gas. And then utility cost savings, not really assume insignificant or neutral. We don't have a heat pump cooktop yet, but if we did, then it would be much more efficient than the ones that are out there now. Operations replacement cost is higher, so reserve replacement budgets need to be adjusted. Induction cooktop surface is the same as smooth top electric, easy to clean and refresh on turnover. Insurance credit for being safer, not yet, but there is an actual reduced risk. And then considering offering a pot and pan set to new residents that work with induction cooking. Not all cookware works with induction. It has to be magnetized, and so you can take a magnet and test a pan, and if that magnet sticks to the pan, then it'll work with induction. If it doesn't, it won't. So that's a good way to test and sort of inform residents whether or not their cookwork is going to work with the induction cooking. Next slide, please. All right, induction cooking maintenance. Cleaning the stovetop to avoid buildup, clean as you would a smooth top, glass coil electric resistance. Give each resident a supply of smooth top cleaner and pads that will help sort of reduce the cleaning that will have to happen by maintenance staff. It is not as difficult to clean as electric smooth top. That is because induction is typically, even though it's able to provide a better cooking performance than electric coil, the actual surface is going to be cooler. So you're not going to have that same like burn mark that you really have to put some elbow grease in to get out. Whereas with induction, you can, if you're boiling water, you can lift the pot up and just run a rag underneath, and it's not going to scald your hand. It's not going to burn your hand. Cleaning the oven is typical procedure. Service parts are available. If you do have to replace a major part, you might want to consider hiring a technician, but some maintenance teams may be able to do some diagnostics and service in-house. So we're going to label that difficulty as medium. Next slide, please. So moving on to solar PV maintenance. Next slide. So lots of components of solar PV systems. You have your panels themselves. You have all of your electrical gear. You potentially have batteries. You have inverters for the solar. You have inverters for the batteries. There's a lot of electrical components here associated with solar PV. Fortunately, most of this stuff is going to be contained within the box and should not need to be replaced, and you shouldn't have to maintain any of this equipment. However, the key to solar PV system or maintaining a solar PV system is monitoring for issues. Next slide, please. So, as I mentioned, monitoring utilities to ensure no failures in the equipment and slash gear is really going to be your best approach to maintaining your solar PV system. If you're using utility bills, it's not always reliable, as you'll typically experience a long time delay. If your solar isn't working for a month and it's at the start of the month, you don't want to find out when you're paying your utility bill. In addition, oftentimes utilities are handled by a third party. So, there could be some confusion there. We definitely recommend enrolling in a performance monitoring system and setting up alerts. The alert should be based on kilowatt hour production usage, not cost. That is because utilities their costs will fluctuate. And so if your alert is based off cost, it could become a false alert. Use a vendor or have a specific staff person to access monitoring equipment and check it monthly. Ultimately, if you don't have a specific staff person, what can happen is people aren't familiar with what they're looking at. They didn't see what they aren't comparing it to the previous month. So having a specific staff person dedicated to reviewing that monitoring data is really your best approach there. And then for maintenance staff, they should be doing visual spot checks, look for exposed wires, bird nests, etc., squirrels, that sort of thing. And then vegetation and landscaping. So oftentimes you want to avoid, all the time you want to avoid vegetation and landscaping shading the panel. So you want to work with your landscaper to make sure that they're trimming back trees to ensure that your panels are getting full sun when they have the opportunity to. And we have some photos here, some examples of why visual inspections are important. The bottom photo looks like those panels were hit by a few golf balls. And then on the right, we have some bird poop from birds flying over on the panel on the right. Next slide. So cleaning solar panels. This is, besides monitoring, and visual inspections, this is an additional thing that you need to be considerate of when maintaining solar PV systems. So solar panels should be cleaned at least twice per year. Oftentimes you'll hear solar manufacturers say that you don't need to clean them because it's going to rain and the rain will clean it. However, what we've experienced from our projects is that often solar panels need to be cleaned, and they do have, by cleaning the panels, you are going to see quite a large boost of kilowatt hour offset or kilowatt hour generation from those panels. So frequency of cleaning panels may vary depending on climate and weather. If you have less rain, you're probably going to have to clean them more frequently. If you live in a dusty climate, you're probably going to have to clean them more frequently. In-house cleaning may not be an option for systems on a pitched roof. If your site staff or your maintenance staff isn't allowed on a pitched roof, you should consider using a vendor or an operation maintenance provider. You can use dish soap or Simple Green, but refer to manufacturer recommendations for cleaning panels. You want to make sure that you're not using something that's going to stain the panel and reduce the amount of solar radiation that can go through the glass and get to the solar cells. Hard water can be an issue. This is a considerate. If you have hard water, you should not be cleaning panels with hard water, because those calcium bicarbonate, those magnesium bicarbonate, that's going to sort of stain the panel and reduce how much solar radiation can go through the panel. Clean on cool days or low power generation times. That's best practice, not required. Cleaning on cool days. If the water is drawing too fast, it can get streaky. If you're cleaning during a time of power generation or high power generation, you're going to get less power generation because you're cleaning. However, you should just do it. It saves you a ton of money, and it significantly improves the kilowatt hour per generation of solar PV systems. And then non-abrasive microfiber cloth. You don't want to scratch the glass. And then buildup of dirt and debris can inhibit solar generation. So it is worth it to do. Especially with larger systems, you're going to see quite a large bump in in kilowatt hour production, and it's most likely going to cover that cost that was associated with having a vendor come out and clean them. Next slide, please. Utility monitoring. So, importance of utility monitoring. Going back to the original sort of crux or the original, myth that all electric buildings cost more to operate and maintain. Ultimately, if you start to have failing equipment, you are going to see it in your utilities. So use utility monitoring software like Utility API, WegoWise, Energy Star portfolio managers. However, by using some of these like free softwares that are monitoring your utilities, you're going to have a delay in the data and the alerts. So you may want to consider using like a building management system. There are lots of options for building management systems. One thing that you need to make sure when you're selecting a building management system is ensure it works with the existing equipment. Sometimes central heat pump water heaters only work with have a port that only work with certain building management systems. So you need to make sure that your system is working properly. And then you have what to look for. Unusual spikes. These can indicate the system is not performing properly and in need of maintenance. Make sure you consider solar PV changes in use based off seasons. So you want to make sure that you're not setting up alerts that are going to falsely alert because it's the winter and you have less solar production, and that's why you're seeing a uptick of kilowatt hour usage. Next slide, please. So, utility monitoring case study. This is an example of when utility monitoring went right, and we were able to find a problem and address it and reduce utility bills. So, we had a project that did a hybrid central heat pump water heating system. Essentially, all that means is that we had not enough electrical capacity to have heat pump water heaters cover the full domestic hot water load at the site. So instead we did heat pump water heaters and a gas water heater as sort of a backup and sort of a top off heater in case the heat pumps can't meet the load. And then heat pumps were located on the roof, and maintenance did not know that they were not operating, because you can typically hear a heat pump, but if it's on a roof, you won't be able to hear it. You won't be able to see that it's operating. And the reason why they weren't operating is because we had check valve issues resulted in the heat pump shutting off. And that could have been caused by hard water. Again, why it's important to make sure that you're flushing those systems frequently. Next slide, please. So utility monitoring case study. This project, we had the gas is in green, the electricity is in blue. This is all in BTUs, so it's all apples to apples. By switching over to heat pump water heating in May of 2017, you can see the reduction in gas. And you can see the uptick in electricity. That is the effect of switching to central heat pump water heaters, and that is the effect of the efficiency difference between gas and heat pump water heaters. However, as we got into April of 2018, you start to see the gas start to increase slightly and the electricity start to decrease slightly. It's very subtle. You see it in 2019 as well. This is an example of why alerts are important. If you don't have a knowledgeable person looking at this utility data, you're not going to really see that change. You're going to be like, oh, I think, it could be anything. But ultimately, it was the water heaters. And in addition, it took 2 years for us to figure out that it was the water heaters because we didn't have a BMS system, because we didn't have monitoring of the system. We were able to catch it, but there was a significant time delay. Next slide, please. So, just touching briefly on utility allowance, make sure to use the appropriate schedule. Space heating, some housing authorities have an electric heat pump utility allowance, which is lower than regular electric space heating one. Air conditioning, do not forget to include air conditioning if you have a packaged thermal heat pump or split systems. Water heating does not apply if you have a central system. Only water utility allowance does if you have a sub-meter. And if you have solar benefiting your tenants, and if your financing stack allows it, you should consider using the California Utility Allowance Credit instead of the Housing Authority Utility Allowance Credit, because the QAC is a little bit better. However, it is not always viable, especially in depressed markets in high AMI communities where the resulting net rent would not pass the below market test for QAC. Next slide, please. Alrighty, working with residents. Resident education. All electric buildings may require resident education to improve tenant experience and efficiency of equipment and operation. That is correct. So all electric buildings may require resident education to improve tenant experience and efficiency of equipment / operation. That is very important. In order to not only in order to maintain the equipment's efficiency, you not only have to maintain the equipment, you also have to train residents and educate residents on how the equipment works. Next slide, please. So resident education best practices, host educational resident meetings / trainings, host cooking demonstrations if you have induction cooking, provide a pot and pan set for new tenants when retrofitting properties with induction cookies, when new tenants provide them with pot and pan sets, but also if you're retrofitting the building with induction cooking, you should provide all tenants with pot and pan sets. All electric buildings may require retraining how folks interact with their HVAC and water heating systems. Recovery, I see it in the chat, it's been a big topic, of heat pump water heaters. So making sure residents understand that, their usage pattern may need to change a little bit if the heat pump water heater's recovery is really low and you weren't able to fit enough storage in there. And then making sure that people understand that heat pumps, just in general, have a slow recovery and heat things up or cool things at a much slower rate. And so, well, I shouldn't say cool things at a slower rate, but heat things at a slower rate, yes. And so, you don't want to be turning up that thermostat up to 90 degrees and then shutting it off. That's going to result in really low efficient operation. Heat pumps like to operate for long periods of time and slowly heat up the space. And so really retraining how, if you have a wall furnace, you're probably used to just like flicking it on, waiting 10 minutes, now your whole unit is hot and then flicking it off. That is not how you should operate a heat pump HVAC system. And then ensure you are selecting an easy to use thermostat. I have another slide on that. And then provide support on how to read a utility bill with net energy metering or virtual net energy metering. Next slide, please. So choosing a thermostat. Consider purchasing a third-party thermostat that is more user-friendly than the manufacturer-provided thermostat. Mini splits are notorious for having remotes. And I imagine as a property manager, asset manager, property owner, a remote is a nightmare. It's going to get lost. You're going to have to replace them all the time. They're also not super intuitive. They can be difficult to use. And so consider purchasing a more user-friendly thermostat, and then provide pamphlets and leave behinds that have instructions for programming and scheduling. Next slide, please. So resident utility bills, interactions with solar and resident utility bills can be difficult to understand. Confirm residents are on the correct utility schedule, especially after rehab. You don't want, if they're on a mixed fuel schedule and you electrified the building, you should make sure that they are on an all electric utility schedule. Provide tenant leave behinds explaining solar benefits if you have solar offsetting the tenant utilities. And then explain utility true-ups, the difference between CCAs versus IOUs, and then also time of use is very important. You need to make sure people understand time of use and sort of promote them altering how they or when they use their HVAC or when they use their water heating in order to reduce their utility costs. Next slide, please. So just a few examples of reading resident utility bills. On the right, you can see this is an SDG&E bill, and you can see that they have negative kilowatt hours used. And we've heard this from tenants where they see, I have a negative kilowatt hour usage. I'm going to get charged next month for that bill because this is a mistake. And they get really concerned about this, and they really start thinking about how are they going to budget for their next month utilities bill. Well, in reality, they are sending more electricity to the grid than they're consuming, and so this is correct. So really making sure that tenants understand that, and then also understanding billing true up at the end of the year. If you've provided excess electricity to the grid, you'll get a credit back. And so really understanding how the true up works and making sure residents understand that as well. Next slide, please. Again, another utility bill. This is an example of how utility bills are set up differently for different utilities. So if you're a portfolio property owner and you have properties throughout California, you want to be considerate of the fact that one training isn't going to effectively teach people how to read their utility bills across the board. You want to make sure that you have specific trainings for specific utilities because they're all different and they all have different approaches. Next slide, please. So previewing our next few trainings, available incentives for electrification retrofits. This should also include solar retrofits or solar installations as well. Next slide. So incentives for multifamily electrification and potential solar. These are all sort of programs and entities that are implementing programs that are available for low income properties and market rate properties for some of them throughout California. Next slide, please. And then we have some potential organizations that could be developing electrification incentives for multifamily throughout California as well. Unfortunately, there isn't a great resource. All of these different funding sources have different requirements. So the recommendation is, look into your local municipality, look into your local utility, and determine what available incentives or what available incentive programs you have based off your specific location. And enroll in a program like the Low Income Weatherization Program is a low income program, but it is all across the state of California. If you enroll in that, they'll find you more funding for depending on your area. So that could be a good option as well. Next slide, please. And then current funding trends. You have your CCAs, you have your municipal utilities, and you have your IOUs. And then you also have your state funding that's all providing incentives for heat pump water heaters, central heat pump water heaters, space conditioning, energy efficiency, and PV and battery. And we're hoping for federal funding coming soon in 2023. And well, we're almost done with 2023, so likely 2024. And I think that is it. Next slide, please. Great.
Thank you, Jack. So I know we're pretty short on time, but we'll quickly dive into some questions that came in through the Q&A. Let's see. So one of the first questions is, how do you monitor heat pump water heaters?
Yeah, there are a lot of sort of third-party monitoring systems out there that are associated with recirculation controls. There are also things like, it's kind of ironic, it's like a save gas monitoring platform, but we've seen it be used for heat pump water heaters. Ultimately, you can also use a BMS system that's going to monitor not only your water heaters, but also your HVAC. So there are a lot of different options. You can monitor just the water heating. You can monitor your water heating and your HVAC systems using a building management system. It really depends on the building type and what other systems you have.
The next question we have is a water softener system as needed if you have a heat pump water heater that uses carbon dioxide instead of heating the water directly?
Sorry, can you repeat that question?
Yeah. So is a water softener system as needed if you have a heat pump water heater that uses carbon dioxide instead of heating the water directly?
Yeah, so essentially what happens is inside the guts of a heat pump, you have these really small flow paths where water is then in contact with the heating coil that has that CO2 refrigerant in it. That water passing through that heat exchanger, that path is so small that you can get gunk and you can get buildup in there, and that's going to result in the unit not operating properly. Mitsubishi has a CO2 unit out there that they actually have a separate heat exchanger that is taking on city water because they don't, and it's outside of their unit because they don't, their concern is that if you have city water, if you have hard water in their unit, it's going to result in a faster failure. So they actually have a water to water heat exchanger outside of the unit that, so the idea is that, you refill if there's a leak. You shouldn't have to refill it, but if you do have to refill it, you refill the Mitsubishi with distilled water, and that is a closed loop, and that is heating water, heating the city water, and sort of like a sacrificial heat exchanger.
Next question we have is, does crossover impact gas-fired boilers and heat pump boilers equally, or do heat pump boilers suffer more?
Thank you. That's a great question. So unfortunately, heat pump water heaters suffer more. And the reason for that is because gas has really high recovery, so it can overcome those really high, that load being inflated due to crossover. And so not to say that heat pumps can't meet that load. Sometimes they can, sometimes they can't. However, what's going to happen is your heat pump is going to operate more frequently, and you're going to see an increase in utilities. And even though you may see a slight increase in gas, you're going to see a bigger impact on heat pump for heat pump water heaters. Our standard when we're retrofitting heat pump water heaters in existing buildings is to test for crossover before, and sometimes we even monitor to make sure that sort of to understand how much of the load is recirculation and how much of the load is just supplying hot water to the tenants. And in some cases, in these old buildings, people weren't thinking about efficiency when they're retrofitting. And so some of these old buildings, you can see recirc loads, like 70% of your water heating load is just from recirculating water. And that's due to crossover. That's also due to imbalance issues as well and uninsulated piping. So with the gas water heater, you're able to cover that load. The heat pump water heater, it can be affected more because of that limited recovery. It's not as resilient to inflated load issues.
The next question we have is, are there increased space requirements needed for replacing a gas water heater with heat pump water heaters? Most gas water heaters are in existing closets.
Yeah, so great question. Thinking about residential water heaters, heat pump water heaters, you're right. In multifamily, the gas water heaters are typically in a small closet. Heat pump water heaters are going to be larger physically because they have that heat pump component, and because they typically require more storage because that recovery is lower. And so finding a location to install those can be difficult. However, what we found is that you can typically physically fit them, and they are making thinner, more like multifamily style heat pump water heaters that are going to fit in those small closets. However, one of the biggest considerations that you have to make is that heat pumps draw heat from the surrounding air. And so if you are in a small closet and you don't have proper air infiltration, or you don't have ductwork that is exhausting that cold air that the heat pump is creating out of that closet, you could run into performance issues. So physical space is a big concern when looking at residential heat pump water heaters, mainly due to the fact of heat pumps are larger because they require more storage and they require proper airflow. So adding that ductwork can also limit the amount of or require more space than a gas water heater. But you don't need a flue. So oftentimes we see people reusing those flues to provide makeup air for that heat pump water heater.
Next question we have is, are there typical issues that occur with induction stoves?
Not that I am familiar with. I think the biggest sort of hurdle for induction stoves is that they can be difficult to use, which is why it's really important to have resident meetings on instructions on how to use them. Some of them have like touch, they're not like super user friendly, and they sort of have hidden buttons on them. So for senior communities, that can be difficult. That's really the main thing that we see with induction cooking, is that they can be less user friendly. So making sure that residents are educated on how to use their induction, and then in addition, making sure that they have the right pots and pans.
Another question is, in a gas to heat pump water heater replacement scenario, how do you deal with the reduced recovery rate of heat pump water heater versus gas?
Storage. So by having more storage, you are able to, the idea of heat pumps is sort of a reverse way of how you size heat pumps versus how you size gas water heaters. Gas water heaters are designed to, the recovery is equal to the first hour or the peak hour draw. So the idea is, like, if your water heater can produce 100 gallons and your peak hour draw is 100 gallons, your gas water heater is going to be able to serve that property. Whereas with a heat pump water heater, the reverse is true. You should be sizing the storage for your peak draw, and you should be sizing your recovery so that your heat pumps can refill that storage with hot water before the next load event. And so really the key to successful heat pump water heating is storage, and making sure that you have enough storage to meet that 3-hour peak load or 2-hour peak load. And it can be done. Having multiple storage tanks, it's complicated, but we've seen 1,400 gallons of storage fit in a multifamily high-rise building in San Francisco. It can be done. It can be challenging, however, and so you want to That's really the key there, is adding more storage. However, it does support future load shifting and even furthers your savings by doing a heat pump water heater if you have more storage.
So we're at two more questions. I know we're at time, so we're just gonna go through those two and then close off our training series. The next question we have is, can packaged heat pump water heaters deliver enough BTUs for central hydronic space heating?
The answer to that is yes. Heat pump water heaters, I mean, the reason why we have heat pump water heaters have less recovery is not because it's a limit of the technology, it's a limit of electrical capacity. And so avoiding that, we could have a heat pump, we could have a tankless heat pump that heats water just as fast as gas boilers, but the concern is the electric draw for kilowatt draw if you're subject to demand charges, as well as just capacity of electricity at the building. And so you really need to be considerate of that. However, can a heat pump water heater provide heating, even cooling, as well as domestic hot water? The answer to that is yes, and there are products available now. We typically don't recommend them yet because they're much less efficient than compared to having two separate systems. That being said, there are products being developed that are going to be low GWP heat pump water heaters that can provide space heating and potentially cooling as well.
So the last question we have mentions, new construction heat pump boiler water quality is questionable. How do you recommend approaching assessment for water softener needed or not needed?
Yeah, so what I would do is I would make sure that if you test the water, you will have grains of calcium bicarbonate and magnesium carbonate by testing that water, and you can refer to the heat pump water heater manufacturer, the heat pump water heater that you're installing, and they will have essentially, do not install this with hard water that is of a certain grain level. And if you see that and you're in new construction, you may want to budget a water softener, or another option could be making sure that you have a pretty aggressive descaling maintenance plan.
Okay, so that finalizes our questions, our Q&A section. And this concludes our training on operations of electric housing. Thank you to everyone for being here with us today. Really quickly before we log off, we once again want to give special thanks to our sponsors, the Wells Fargo Foundation and Energy Efficiency for All. A special thanks to our housing partner, SCAM, and thanks to our program partners, LiveWhip, MCE, Soma, Tech, and Build. And especially thank you, Jack, for such an informative training. It was very helpful. I'm sure folks will take this information back to the organizations and share more about electrification. And lastly, we would also appreciate if you take the time to take the post-training survey. It's on the SurveyMonkey. This will be very helpful for future webinars and how to further best present our information. And we just hope to see you all next week for our session 4, accelerating electrification with solar energy. Thank you all for being here today.
Thanks, everybody. And thanks, Angel.
Thanks, Jack.